Alright, here we have a reaction involving mercury and bromine forming a compound, and it wants to know what mass of this compound is produced from the reaction. And we are starting with 5 milliliters of mercury. And we have plenty of bromine, is what it's telling us. We also know that the density of the mercury is 13.6 grams per milliliter. All right. Now, you generally have to start with what you're given. So we're starting with the mercury. But we aren't given a mass of mercury or moles of mercury. We are given a volume of mercury. Now, since you're also given a density, you can use the density to find the mass of mercury. And then once you get the mass of mercury, this is just like any other problem. All right, the whole object is to get to moles. So we use the periodic table to get to moles of mercury. And then we use the ratio from the reaction. It looks like it's a 1-to-1, or 1 mercury for every one of the compound. So ratio to get to moles of HgBr2. And then it wants to know what mass, so you convert to grams of Hg, mercury bromide. And I'm just going to start saying molar mass instead of periodic table. Molar mass. All right, so we have 5 milliliters of mercury. You can use density just like a conversion factor, or you can do it in separate steps. I have 13.6 grams for every 1 milliliter of mercury. The molar mass of mercury is 200.5 grams per mole of mercury, per 1 mole of mercury. For every 1 mole of mercury, I have 1 mole of mercury bromide. And then the molar mass of mercury bromide is 360.39 grams per mole of mercury bromide. And that gives me 122 grams of mercury bromide.